Assalamualaikum dan salam sejahtera semua. So, ini adalah video chapter 13 part 1 untuk subtopik 13.1 dan 13.2. Okay. So, tajuk chapter 13 adalah gas laws and kinetic theory. 13.1 Ideal gas equation. Okay, learning outcome 13.1b. Discuss the following graph of an ideal gas. First, pressure against volume graph at a constant temperature. Second, volume against temperature graph at a constant pressure. And then the third one is pressure against temperature graph at a constant volume. Okay, look at the first column. Okay, this is for Boyle's law. Okay, so Boyle's law states that the pressure of a fixed mass of an ideal gas at constant temperature is inversely proportional to its volume, or P directly proportional to 1 over V. Okay, P inversely proportional to V if temperature constant. So PV is constant. So we have this kind of graph, okay, where pressure decrease when volume increase. Okay, so the equation for Boyle's law is P1 V1 equals P2 V2, where 1 indicates initial and 2 indicates final, or you may also write Pi Vi equals Pf Vf. Okay, and then the second column is for Charles' law. Okay, Charles' law states that the volume of a fixed mass of an ideal gas at constant pressure is directly proportional to its volume. Volume directly proportional to temperature if pressure is constant. So, volume over temperature is constant. Okay, so we have this kind of graph where V directly proportional to T. So, V increase when temperature increase. Okay, and the formula is V1 over T1 equals V2 over T2. Okay, where 1 indicates initial and 2 indicates final, right? So you may also write Vi over Ti equals Vf over Tf. Okay, next is for Guy-Lussac's law. Okay, it states that the pressure of a fixed mass of an ideal gas at constant volume is directly proportional to its temperature. Okay, so Guy-Lussac's law, also called pressure law. Okay, so pressure directly proportional to temperature if volume constant. So P over T, pressure over temperature is constant. So we have this kind of graph. Okay, P directly proportional to temperature. So P increase when temperature increase. So the equation for pressure law, okay, is P1 over T1 equals P2 over T2. P1 over T1 equals P2 over T2, where 1 indicates initial and 2 indicates final. So you also can write Pi over Ti equals Pf over Tf. Ideal gas is defined as the perfect gas which obeys 3 gas law, Boyle's, Charles, and pressure law. Okay. The other name for Guy-Luszak's law is pressure law. Okay, it is easier. Exactly. Okay. Ideal gas is defined as a perfect gas which obey three gas law exactly. Therefore, we can combine all three equations to get PV over T is constant. So many problems involve a change in the pressure in unit Pascal, temperature in unit Kelvin, and volume in unit meter cube of a fixed amount of gas, okay, which is constant mass. If we now let P1, V1, and T1 represent the appropriate variables initially, and P2, V2, T2 represent the variables after the change is made or final, then we can write equation P1 V1 over T1 equals P2 V2 over T2. Okay, 1 mole of gas at standard temperature and pressure, or it is known as STP, okay, where temperature at 273.15 Kelvin and pressure at 1 atm. Okay, 1 atm. ATM is unit for pressure. Okay, so 1 atm is equivalent to 101.3 kilopascal. Okay, and volume, standard volume is 0.0224 meter cube. So the equation above, okay, that's mean the equation PV over T just now, okay, PV over T, okay, so R equals PV over T, okay, so we can calculate R, okay, substitute P, where P is 1 atm, okay, but pressure should be in unit Pascal, so 1 atm equivalent to 101.3 kilopascal, or 1.013 times 10 to the power of 5 Pascal. Okay, ini tukar kepada daripada kilopascal kepada Pascal, and then volume, okay, at standard temperature pressure is 0.0224 meter cube. Okay, volume mesti dalam meter cube, and temperature mesti dalam Kelvin, 273.15. So we get R equals 8.31 joule per Kelvin per mole. Okay, so R is called molar gas constant. Okay, so actually R ni akan diberi, okay, R will be given, okay, in list of formula and its value is the same for all gases. Okay, nilai R ni sama untuk semua jenis gas. Okay, thus PV over T equals R. So ini adalah untuk 1 mole. Okay, PV over T equals R ni adalah untuk 1 mole of gas. So PVM equals RT. Okay, untuk 1 mole of gas, where Vm is volume of 1 mole gas. Alright. So for n mole, okay, n is number of mole. Okay, maybe 2 mole, 3 mole, whatever value of mole of an ideal gas. So the equation of state is written as PV equals nRT, where n is number of mole. Okay, untuk gas yang bilangan mole dia tertentu, kita kena guna equation PV equals nRT dan gantikan N ni adalah number of mole. Okay, so number of mole sebenarnya ada banyak formula. So salah antaranya adalah number of mole equals M kecil ni adalah simbol untuk mass dan M besar ni adalah simbol untuk molar mass. Okay, so number of mole equals mass over molar mass. Okay, and then number of mole, satu lagi formula dia adalah N over Na, where N is number of molecules and A is Avogadro's constant. Okay, Avogadro's constant. So nilai dia ni akan diberi dalam list of constant value. Okay, dekat calculator pun ada. Okay, dalam chemistry pun kamu selalu jumpa lah. Okay, Avogadro constant. And A ni adalah Avogadro constant. Okay, so kamu boleh juga dapat number of mole daripada number of molecule divide with Avogadro constant. Okay, Avogadro constant nilai dia adalah 6.03 times 10 to the power of 23. Okay, so if the Boltzmann constant K is defined as K equals R over Avogadro number, okay, so value of K is 1.38 times 10 to the power of negative 23 joule per Kelvin. Okay, nilai K untuk physics, okay, tak sama dengan nilai K untuk chemistry. Okay, so kena pakai, kalau untuk physics kena pakai yang ini 1.38 times 10 to the power of negative 23. R pun sama. Okay, R untuk physics adalah 8.31. So chemistry lain. Okay, so kena pakai untuk fizik pakai yang R 8.31. Okay, nilai R tu berbeza untuk chemistry dan fizik sebab nilai STP tu unit dia berbeza lah. Okay, contohnya di standard temperature pressure, contohnya pressure dalam bila kita nak calculate R tadi, pressure untuk fizik kita pakai dalam unit Pascal. Okay, dalam chemistry mungkin pakai dalam unit ATM. Okay, dan unit-unit lain lah, unit bagi temperature, okay, and then volume. Okay, sebab tu nilai dia lain. Okay, nilai K dan nilai R ni adalah ada dalam list of constant value. Okay, untuk final exam nanti. Okay, so tak perlu hafal lah sebenarnya nilai K dan R. Okay, so K equals 1.38 times 10 to the power of negative 23. Then the equation of state becomes PV equals NKT. Okay, so yang ni juga adalah formula untuk ideal gas. Tadi adalah PV equals nRT. N tu adalah N kecil, tu adalah number of mole. Satu lagi formula adalah PV equals NKT. N dalam ni adalah number of molecule. Seterusnya adalah relationship between number of moles, number of particles, mass and the volume of gas. Okay, boleh go through diagram ni. Okay, untuk conversion unit. Alright. So equation of number of moles. Okay, so number of moles ada 3 formula. Okay, first, number of mole equals mass over molar mass. Okay, pastikan unit mass dan unit molar mass mestilah sama. Okay, standard untuk molar mass biasanya memang dalam gram. Okay, molar mass biasanya memang dalam gram. Jadi unit mass ni mesti kamu tukarlah kepada gram. So untuk samakan dua-dua unit ni, ataupun molar mass ni convert kepada kilogram dan mass mesti juga dalam kilogram. Okay, baru akan dapat nilai number of mole yang betul. Okay, satu lagi formula adalah number of mole equals number of molecules over Avogadro number. Okay, dan yang ketiga adalah number of moles equals volume over molar volume. Molar volume ni adalah pada STP nilai dia adalah tadi 0.224 meter cube. Okey. 0.224 meter cube. Okey, so kita nak proceed kepada 13.2 kinetic theory of gases. So in subtopic 13.1 we discuss the microscopic properties of an ideal gas including pressure, volume, number of moles and temperature. So in this subtopic 13.2 we consider the ideal gas model from the microscopic point of view. So the microscopic behavior can only be described by the kinetic theory of gases. Okay, so teori dia teori kinetic theory of gases. Okay, ada beberapa assumption. Okay, kinetic theory of gases model makes the following assumption. First, all gases are made up of an identical atoms or molecules. Okay, so gas ni terbina dari atom yang sama jenis. Okay, atau molekul yang sama jenis. And then all atoms or molecules move randomly and haphazardly. Okay, dia bergerak secara rawak. Okay. And then the third one, the volume of the atoms or molecules is negligible when compared with the volume occupied by the gas. Okay, volume bagi atom dan molecules ni adalah negligible. Okay, when compared with the volume occupied by the gas. Okay, and then the fourth, the intermolecular forces are negligible except during collisions. Alright, and then interatomic or molecular collisions are elastic. Okay, dia adalah elastic collision. Maksudnya, bila elastic collision, maksudnya total kinetic energy initial equals total kinetic energy final. Ataupun kinetic energy is conserved. Alright. And then the duration of a collision is negligible compared with the time spent traveling between collisions. Atoms and molecules move with constant velocity between collisions. Gravity has no effect on molecular motion. Okay. And then kita akan discuss learning outcome 13.2b. Discuss root mean square speed. Okay, simbol dia adalah VRMS. Okay, RMS ni stand for root mean square of gas molecule. Okay, the quantity mean square ni adalah simbol untuk mean square. Okay, yang macam arrow ni mean, and then ada kuasa 2 ni square. So yang ni mean square. Okay, the quantity mean square is the mean square speed of all atoms in the gas. It means that we first can find the square of the speed of each atom and then find the average of these squared values. Alright. So VRMS is defined as square root mean squared. Okay, square root mean squared. Okay, so by comparing the ideal gas equation, PV equals NKT and PV equals 1 over 3 and M mean squared, then equating these two equations, we get NKT equals 1 over 3 and M mean squared. So mean squared V equals 3 kT over m, where m is mass, okay, T is temperature, K is Boltzmann constant. Okay, so daripada equation tadi, mean squared equals 3 kT over m. Therefore, VRMS is equals Z 3 kT over mass. And VRMS equals square root 3 RT over molar mass. Alright, so equation ni boleh je pakai mana-mana satu untuk cari VRMS. Okay, kalau dia bagi mass, so kena guna formula yang ni lah, 3 kT over mass. Cuma careful, mass kat sini mestilah dalam kilogram. Okay, mass kat sini mestilah dalam unit kilogram. Okay, atau dia bagi molar mass, soalan bagi molar mass, nak cari VRMS, boleh pakai formula Z 3RT over molar mass. Sini pun kena careful, molar mass standard dia dalam gram. Jadi bila nak substitute dalam equation VRMS, molar mass mestilah dalam unit kilogram. So kena convert lah dari gram kepada kilogram, and then baru substitute dalam formula VRMS. Since pressure equals 1 over 3 density mean squared, thus mean squared equals 3 pressure over density. Therefore, VRMS is also equals square root 3P, P pressure, over density. Okay, rho. Rho ni adalah density. Okay, ni satu lagi formula untuk VRMS, 3 times pressure over density. Okay, dalam ni careful, pressure mesti dalam unit Pascal. Okay, kalau dia bagi dalam unit ATM, kena convert lah kepada Pascal. Conversion unit untuk yang pressure dari ATM kepada Pascal ada dalam list of constant value. Okay, and then yang ni density, density of gas. So density ni mestilah dalam unit kilogram per meter cube, kg m negative 3. Okay, so dalam tiga-tiga formula tadi, okay, ada 3 formula untuk VRMS. Okay, so VRMS adalah root mean square velocity or speed, and then K is the Boltzmann constant. Okay, so nilai ni ada dalam list of constant value, and then M is mass of a molecule gas. Mass ni mesti dalam kilogram, and then T is absolute temperature, maksudnya dalam unit Kelvin. Temperature mesti dalam unit Kelvin. And then R 8.31, value ni juga ada dalam list of constant value. Okay, M is molar mass of gas, juga mestilah dalam unit kilogram. And then P is symbol for pressure by the gas. Pressure macam saya cakap tadi, pressure mestilah dalam unit Pascal. Okay, dan Pascal ni adalah setara dengan Newton per meter square, and M negative 2. Okay, unit lain bagi pressure adalah ATM. So kalau dibagi dalam ATM, you must convert to Pascal. Okay, conversion unit dari ATM kepada Pascal ada dalam list of constant value. Okay, and then ni rho. Okay, yang macam P kecil ni adalah rho. Simbol ni nama dia rho. Ni adalah density of the gas. Yang mana sebenarnya density ni boleh dapatlah dari formula density equals mass over volume. Okay, so unit mass mesti kg, unit volume mesti meter cube. So unit bagi density mestilah kilogram per meter cube, kg m negative 3. Okay, let us discuss about gas pressure on the wall container. Okay, gas consists of atom or molecule. Alright, molecules are in the state of random motion. Okay, it always moving. Okay, kalau tengok dalam eksperimen gas boleh nampak yang kalau kita colorkan gas tu, kita boleh nampak lah yang molecule of gas always moving and always collide to each other and collide with the container. Okay, so they will collide with one another and with wall of the container. The total force exerted on the wall is given by this formula. F equals N/3 M mean squared over D. Okay, formula ni sebenarnya datang daripada beberapa assumption. Okay, ada 4 slide lah untuk describe ataupun untuk discuss datangnya formula ni. Okay, tapi untuk silibus kamu tak perlu ingat yang itu. Okay, tapi kalau berminat untuk tahu detail macam mana datangnya formula ni, okay, boleh PM saya, nanti saya akan bagi detail lah untuk bahagian tersebut. Okay, formula F ni. Alright. Okay, when the molecules collide with the wall container, the molecules will rebound. This will cause change in momentum. Alright, so the rate of change of momentum will produce a force. Okay, this one come from Newton's second law. Okay, the rate of change of momentum will produce a force on the walls of the container. So, the force per unit area is defined as the pressure on the wall. So, formula for pressure is pressure equals force over area. Yang mana formula force tadi datang dari slide yang sebelum ni. Okay, N/3 M means squared over D. And then area. Okay, area katakan bentuk container ni adalah bentuk square. Jadi area dia adalah D squared. Alright, D times D, or length times length. Alright, and then simplify this equation. Okay, simplify this equation, we get 1/3 and M means squared over D cube. Okay, and then kita kumpulkan volume. Okay, kat sini, and M over V. Okay, sebab ni datang daripada D cube ni, D cube, D times D times D. Okay, or length times length times length is the volume. So kat sini dapat NM over volume. Okay, volume ni datang dari D cube ni. Okay, time means squared. So arrange this equation, we got this equation. PV equals 1/3 and M mean squared. Okay, PV equals 1/3 and M mean squared. Since the density of the gas rho is given by rho equals number of molecules times mass over volume, hence the equation can be written as, okay, pressure equals 1/3 density times mean squared. Alright, pressure equals 1/3 density mean squared. Okay, P is pressure of the gas, should be in unit Pascal or Newton per meter squared. V is volume of the gas, should be in unit meter cube. N is number of molecules, and M is mass of each gas molecule, should be in unit kilogram. And then this one is mean square speed or mean square velocity, and then this is the symbol rho. It is the density of the gas, and the unit should be kilogram per meter cube. Kg m -3.